Hello, everyone. I'm Eric Schluntz. I'm the co-founder and CTO of Cobalt Robotics. We build friendly indoor security robots that use human-in-the-loop control to help keep buildings and companies safe. So Cobalt was started when I left SpaceX and my co-founder Travis left Google X with actually no idea what we were going to work on. We thought that too many companies built something that it turned out no one actually needed. So instead of looking for a startup idea, we would go look for a problem and an opportunity. We spent about a month interviewing people in lots of different industries, looking for one of these opportunities and trying to understand what people did day to day. And we found an amazing opportunity: nighttime security. We talked to a director of security at a company here in San Francisco, and he told us everything we learned about it. We learned why cameras alone aren't enough. There's no real-time response as something's happening. The point of view is never perfectly correct. We also learned that us humans are pretty bad at doing security as well. We fall asleep, we get distracted and bored. It's really hard when actual security events are so rare. So we set out to build the Cobalt robot. It patrols around autonomously, looking for people or anything out of the ordinary. And when it does detect something, we video call in a human-in-the-loop robot specialist to handle the situation. So we can still provide a friendly human face as part of the interaction, but keep the reliability and cost savings of a machine for most of the time. And because these security events are so rare, we can basically have one person managing a fleet of 10 or 20 of these robots. And security is really just the start. We think that we've built the iPod of robotics, where it's a single-purpose thing where we've really engineered it to do one thing amazingly well. But what comes after the iPod is the iPhone. And we want to be building something that's a general-purpose robot, where it can do lots of things, not just nighttime security, but helping deliver packages, helping facilities issues, being a virtual receptionist during the day. And I really don't think that Steve Jobs could have imagined what would happen when every single person carried a general-purpose computer in their pockets. And I really don't think we can imagine once every single building in the country has a general-purpose robot in it. So back to today. We have a small engineering team, and I think one of our biggest challenges is detecting people. There's lots of great open source models, pre-trained, put out by great research organizations and academic institutions. And we hit a problem that I don't think any academic had thought about: telling apart people from pictures of people. So when the robot says Justin Bieber's a person, it's not necessarily wrong, but it's also not very useful. I don't want this to set off alarms every single time the robot goes past this poster. And you have a lot of these in our customer sites, way more than you'd ever imagine. So we thought about how to solve this. There's a couple ways. We have a high-end thermal camera, we have depth cameras, but they're all on the front of the robot. And these cameras are 360 degrees. And we really don't want the robot to have to stop and turn and admire every single Justin Bieber poster that it sees. It would be a very distractible security robot. So we realized we could actually solve this problem by cheating. We don't have to handle this for a completely new situation. We can annotate information and save this semantic information as we go for the next patrol. But saving semantic information and annotating a single image isn't enough. The robot is going to pass this poster hundreds of times and see it from all different angles and all different points of view. So we need to combine this information with a 3D understanding of where this false positive is on our map. Then we need to ray trace and figure out, when we're detecting a person, where in 3D space this image is coming from, so that we can see if it lines up exactly with one of our pre-known false positives. Lastly, it's not enough to know where the camera is right now. We need to actually ray trace from where the camera was milliseconds ago when the image was captured by the sensor, or else all the data is wrong. And lastly, there's one fun extra challenge that if we have any chance of defeating a cartoon burglar who's going to go and stand right in front of a poster, we need to do a final confirmation and make sure that the image that we're saying is from this false positive actually maps up pretty well. So this is a fun challenge we had in computer vision. We have a lot of other fun challenges in front end, creating low latency interfaces to control these robots, in mechanics, keeping these robots reliable over multiple year lifespan, in machine learning, in lots of things. So if you're interested in any of this, or you want to come meet the robot, come chat during the break. Thank you.